Hello and welcome to the Last Architect channel, where we show you tools for modern architectures and best practices for IT. Today we are going to integrate a new library into our WODA framework. We will make a component out of the library so that it can be used with drag and drop in the future. For today's exercise we chose the float library for line graphs and bar graphs and pie graphs, like in this simple example. Float charts is used widely in IoT projects. It is very mature, it has lots of functions and allows you to create a variety of different diagrams, like in these examples. First, we need to create a component in our framework. We navigate to the main component repository and select the default user, which is admin. But we log in as demo user with the secret password and we get access to the Neo4j database. The repository is a domain structure like the Maven repository, and the domain for floatcharts is floatcharts.org. So we navigate to org, and in components.org we create a new namespace named floatcharts. Inside this new namespace we create a UCP component called float. We enter the type UCP component and the name, float. For components, the convention is to start with a capital letter, like in good Java tradition. WODA creates for us all the necessary files and the structure, which are required so that the component can exist in different versions. We get, as a result, a fully functional component which we can drag and drop into any part of our web page here. Initially, it is filled with template code from a standard Bootstrap panel. Therefore, it also looks like a Bootstrap panel initially. Let's bring this up in Visual Studio Code for further inspection. In Visual Studio Code, we see the exact same directory structure on the left-hand side, all the way down to our web bean with the HTML and to our float class with the JavaScript code. We now have to fill this in with real code from the float charts example page, and we'll show you how to do this. The basic example shows what it's going to look like once we get it working. And we take a look at the source code. At the top it has the dependencies, the other libraries that are called by this code. At the bottom there's the HTML with a placeholder, which will, during runtime, get replaced by what these JavaScript classes compute. The code has at the top the arrays with data, has one line of code that plots into the placeholder. Now it's time to modify our template code. The class has to be the same name as the UCP component and its folder. We do not need to implement this as an interface, so we get rid of all of that code. We rename the variable and the class to float. The override server descriptor we can set to true to facilitate working offline. And in the dependencies section, we have to list all the dependencies so that this code gets loaded before the components are actually used. The float component will, of course, only work with the original code libraries from the float website. Our dependency here for this basic example are jQuery and jQuery.float. There are a lot of other dependencies which we'll see when we download the source code from GitHub. We can embed the source code directly into our own structure, into the framework files we created previously. We go to the base directory of our component, which is org floatcharts float version 1.0, and into the source directory. And from the float website, in the API section, there's a link to clone the repository, which we copy into our git command. Downloading code from GitHub is most easily done through the command line interface. Here's the link which we need. There's a button to actually copy it, and we can paste it into our own command. The download took about 2 seconds and created a local directory with the name flot. If we look inside the directory, we see that about a dozen libraries was loaded in the process. And the two that we need, the jQuery and the jQuery.flot, are present. We use the less command to check that they actually contain what we expected. And now we copy the whole path name, including the file name, and we paste it into our own source code in the dependencies section. The pasted string needs a little bit of cleanup here. All of these dependencies are loaded before the first instance of an object is even created. So these are all static functions. A good component describes itself to the outside world. The name, description, and badge are strings to let the user know what the component does. So we override the strings with something meaningful for our own component. The attribute, property, and relationship are not needed, so we get rid of them. Our next task is to fill the component with code and default data, which we get from the example program. We will start with D2, which is an array with 4 points. Plot function, however, expects an array of arrays. So in our program, we will have to wrap it in another set of angle brackets. The additional methods are available if you want to do something more complex. Since we just got rid of property 1 and the subcomponent, we can delete the corresponding methods as well. After drag and drop, the onDom ready method is called, and our web bean only creates a placeholder, a simple div statement. The div acts as a default view for each component. So the code here becomes really simple. If you are not a default view, return, do nothing. But if you are, render yourself in the placeholder div. The rendering is handled by one line of code with the plot statement, which we get from our example code. The plot function needs as input the data array which we just specified, and it is referenced by this model data. Now over to the web bean. The panel code is not needed anymore, and we reduce it to a very simple div placeholder with one line of code. Here we see that we can add CSS information to the div, which is loaded from the model. But our model doesn't even have CSS classes yet. So we need to add one and give it a defined value, even if the value specifies an empty string for now. But this empty string could specify size information or other CSS values. Now the question is, how big should our placeholder be? We need to give it some default values for width and height, but we want to be able to control them dynamically. We add the width and height parameters as style information in the div, and we fetch the actual values with this model width and this model height. The width and height also need to be added to our model data. For now, we'll hard-code them to 400 pixel wide and 300 pixel high. Now we need to find a way to reference this ID. The framework gives each placeholder an ID, and strictly speaking, we would have to tell the plot function, find the object with this ID. But there is an easier way. The onDom ready method is passed a view when it is called, and the framework stores the element ID in view.documentElement. This happens to be the element which jQuery would look for and we hand it over directly so that the plot method can plot directly into the div element. It took just over 10 minutes to convert the basic float library into a component. From now on, a user can use the new component with easy drag and drop. We navigate to org floatcharts.float version 1.0, and the user can just take the XML descriptor and drop it into overview, or push it to the top of the stack first. The data we entered into the model section are exposed to the outside world. We can modify these values, and the component will respond immediately and reconfigure itself. In the next video, we will add more functionality and start using this component. If you enjoyed it, give us a like or join the club at wo-da.de.